Assalamualaikum. In this video, we are going to discuss the fitting of binomial distribution to a given observed frequency distribution. In fitting a binomial distribution, the first step is to estimate the parameters of the distribution from the given observed frequency distribution. So first of all, we have to estimate n and p based on the observed frequency distribution. How can we do that? We can do that by using the concepts that the distribution the mean of binomial distribution is always equals to np and variance equals to npq. So we can compute mean from the observed frequency distribution and variance from the observed frequency distribution, and then use these two values to estimate n and p. After estimating the parameters, we will calculate the theoretical probabilities using the estimated parameters. Once we estimate our parameters n and p, we will calculate all the probabilities using the binomial formula, which is ncx, p raised to power x and q raised to power n minus x for all the values that range from 0 to n. So the second step will be to calculate probabilities, and in step 3 we will calculate the theoretical frequencies. How can we calculate the frequencies? It is simple. We can multiply the sum of frequency, which is n is sum of frequencies, which will be given in our observed frequency distribution, and we can multiply it with all the probabilities. We will get the estimated or theoretical frequencies. So let's do this through an example. We are considering a question as an example from our book. What does it states? The incidence of defective items in 200 samples of 6. We have taken 200 sample of 6 items is shown in the following table, and x denote the number of defectives in the sample of 6 when we have taken 200 samples. So number of defectives are 0, 1, 2, 3, 4, 5, 6, and the number of samples which have 0 defectives is 36, with 1 defective 70, and so on. And total there were 200 samples. What do we have to do? Assume these results follow a binomial distribution, which is quite evident from the situation as well. Compute the theoretical binomial probabilities and frequencies. We have to calculate binomial probabilities and frequencies. Here we have information about the sample size. We have two parameters of binomial distribution. It's n and p. So we have an estimate of n here. We don't have to estimate it, since we know that x ranges from 0 to n, and we in binomial distribution we are observing x out of n successes. So it is given in this statement. So n would be 6. It is evident that we are considering the number of defectives out of 6 items, so our 6 would be our n. Now we have to estimate p. So what would we do? We will use mean and variance. Since we have one unknown, so we will need only one quantity. So first of all, let's copy this to our page. So this is our frequency distribution. First of all, we have to estimate p. So we will use mu is equals to np. Since we don't have mu, so we will use estimated value of mean, which is, from a frequency distribution we can estimate using the formula summation fx over summation f. So we will calculate mean, and then we will estimate our p. Here n is given, which is equals to 6. So first we will estimate mean. For mean, we have to calculate summation f of xi and summation fi. We have summation fi, which was 200. Now we have to calculate summation f of xi. We can do this by method we already know. We will multiply f and x and then sum the column. Let's do it. So we have calculated the multiplication of two column f and x, and the total is 300. So our mean will be 300 divided by 200. So it's simply 3 by 2, or we can write it as 1.5. So let's use this in this equation. So we will get 1 mu hat equals to np. Substitute all the values. We have mu is equals to 1.5, n is equals to 6, n is equals to 6 into p. So p will be 1.5 divided by 6, and it turns out to be 0.25. It's 0.25. So what will be our q? Q will be 1 minus p. So q will be 0.75. So we have all the parameters. Now we can use our binomial probability distribution to calculate all the probabilities. Here we have n is equals to 6, ncx. pm probability mass function क्या बन जाएगा हमारा 6cx. p क्या है 0.25 raised to power x and 0.75 raised to power 6 minus x for x 0 1 2 up to so on 6. So we will construct a table again and we'll calculate our probabilities. So let's do this. X 0 1 2 3 4 5 6, and then we will calculate probabilities, and then we will calculate theoretical frequency. So let's calculate all the probabilities using the probability mass function of binomial distribution. So let's do it. So I have calculated all the binomial probabilities using the binomial probability mass function. So these are all the probabilities. To get the theoretical frequencies, we will multiply these probabilities with capital N, which is 200. So for first frequency, we will multiply 200 with 0.177978, which will be 35.6. So in similar manner, we will calculate all the theoretical frequencies. Let's do it. 200 multiplied by 0.355957, which is 71.19. Continued in similar fashion. So we get all the theoretical frequencies for the binomial distribution. So the thing we must ensure is the sum of probabilities should be equals to 1, and sum of theoretical frequencies should be equals to sum of the observed frequency, which was 200. So this is the fitted binomial distribution. So we have fitted the binomial distribution to the observed frequency distribution by estimating our parameters from that observed frequency distribution. So this is our final form of the distribution. So this was our observed frequency distribution, and this is our theoretical frequency distribution. So